Welcome to another Stoddard tutoring tutorial. In this video, I will work through the OpenStax first edition, chapter 15, problem 15a. This is the problem. It's a bit wordy, but we are essentially working with silver chloride that's a solid, insoluble, right? Sparingly soluble in a solution of 0.025 molar sodium chloride. So the first thing we want to do is write the equilibrium out for the solubility reaction. We have silver chloride in equilibrium with silver ion, which is aqueous, and chloride ion, which is also aqueous. You should know the charges of silver are +1 and the charge of halogens are -1. Be sure to always write the states in these equilibria. This equation is balanced, so we can go ahead and move on to the next step. Now what we want to do is set up an ice table with common ion concentrations. So let's go ahead and set this table up. So the molarity of chloride is 0.025 molar. That's from the solution that it's in. There's no silver ion present initially in this sodium chloride. And just to make sure every entry is filled in, I'll just put a 1 under the silver chloride so our table's filled out. Next, we need to recognize that this reaction will shift to the right to reach equilibrium. So we're going to go ahead and put a +x under silver ion, the 0, and we're going to put +x under chloride. Those are both on the right side of this equilibrium. I'm going to put a -x here to complete this side. Now, to calculate equilibrium concentrations, we just add the two top numbers. So we have 1 minus x in this column. The silver ion, we have x, and the chloride ion, we have 0.025 plus x. All right, so now we know the equilibrium concentrations of each of the ions. And we want to go ahead and, in this step, write out an expression for KSP and solve for x. So let's go ahead and do that. So KSP is equal to the silver ion concentration times the chloride ion concentration. And I went ahead and looked up the KSP for silver chloride that I found in Appendix J of the OpenStax book. So now we just substitute these values into the expression, and we have 1.6 times 10 to the minus 10th is equal to x times 0.025 plus x. Now, a key to solving this problem is to assume x is very small. We can make this assumption because KSP is very small. So we can simplify 0.025 plus x to just 0.025. And now we can very easily solve for x. X is equal to, after doing the algebra and calculator work, 6.4 times 10 to the minus 9. Now, x is just a tool to help us figure out ion concentrations. So we want to go ahead and plug this back into the ice table. This gives us a silver ion concentration of x, or 6.4 times 10 to the minus 9. And the chloride ion concentration is 0.025 plus that very small number, which after rounding just gives 0.025. So these are the two concentrations of the ions. Since silver chloride is a solid, we don't need to calculate anything about it. So this here is a list of the steps if you want to take a look at that. If you like this video, be sure to give me a thumbs up and subscribe for more videos like this. Have a nice day.